Exercise 2, Metallurgy. We're going to go ahead and take a look at SolidWorks functionality when creating a structural steel frame with Weldments Tools. Once we complete the frame, we're going to go ahead and run a SolidWorks simulation analysis on the frame. So let's begin. This is what our frame is going to look like. As you can see, the parameters were about 24 inches high off the ground, and then we've got a 40 by 30 frame. So let's start a new part file. Select the top plane and start your sketch. Take the center rectangle tool, and at the origin drag out your rectangle and dimension it at 40 by 30. Now from here we're going to go ahead and just hit rebuild. So we got our tabletop. The next thing we're going to do is we're going to go ahead and select the front plane from the feature tree and hold control and select the front edge of that tabletop that you've done with the control key. And now we could go to features, reference geometry, plane, and essentially we're just creating an offset plane on that end so we could draw a leg. Now go ahead and click on this plane and start a sketch. To go to the front view orientation, and we're going to go take the line tool and on this end click and drag off a line, and then go ahead and find the midpoint and attach it to this edge. Now what we're going to do here, and from here we're going to go ahead and put some dimensions in. So we'll make it a leg 24 inches long. Oops. And then just dimension the angle between the two at 45 degrees. Now you'll see it's still blue. That's because we might have to actually reattach it properly to this end. I have to just grab it, drag it towards it, and that should lock it in. This one too, remember you can always hold control and select the line and make them coincident if it's still blue. Alright, again we hit rebuild. You'll probably want to hide the plane. Just right click on the plane either from here or the feature tree. Find plane 1 and find the little pair of eyeglasses to hide it. Now at this point we're going to go ahead and move to our Weldments Tools. Now if you don't see your Weldments tab, right click on any of these tabs and just select the Weldments tab. And then you can hit the tab once it shows up and find structural. First of all, we want to click on Weldments to transform this into a weldment part. And then go to Structural Members. And then you'll see there's an ANSI inch. We're going to go with square tube and the 2 by 2 by 0.25. Go ahead and select this edge, then the front, and go around counterclockwise. It really doesn't matter, clockwise or counterclockwise. Go around. You'll see that they are automatically mitered, the ends. And so you have to click on these little pink dots. Click on it, and then you can change the miter. Like I'll go with end button 1 here. Take a close look at what it looks like. Apply. Do the same over here. Click on the pink dot. Probably they always reverse, so they're opposite. So end button 2. Click on the dot. End button 1 and end button 2. Okay, from here, now we could go ahead and, rather than just hit the green check mark, we could add a new group for the vertical. So now click on this line here, and click on for a new group for the 45-degree angled line. All right, and again, you could adjust the end butts if you prefer on these, but I'm going to leave them as is and hit the green check mark. Now typically what I like to do is hide these sketches. So you see sketch 1, right click on it in the feature tree and you'll find the little pair of eyeglasses, which is hide. Do the same to sketch 2, right click and hide. Now what we're going to do at this point is you can design all the sheet metal, or I should say the weldment features that you want into this right now, but later on just be aware that you have to suppress some of them, like the end caps and things like that. So for example, we have end caps we can put on here, and you just have to find the end cap tool Specify your thickness, direction, inward or outward, and in this case we'll stick with outward. Now the thickness ratio and the chamfer corners, let's put a 0.25 chamfer on those corners. You just select the end faces like that. Rotate it around. And select all those and hit the green check mark. So there's our end caps. And in fact, what we might want to do here is create a configuration. Right click at the top. Actually, not right click, I'm sorry. Click on this little configuration manager tab at the top. And at the very top where you have part 1 or whatever you named it, right click and you want to add configuration. We're going to call one configuration FEA, and this is our analysis. Okay, and the default is what we're working on. So double click on default. What this will do is any features we add now won't be added to the FEA. Oh, you know, I probably could have done this later on, but regardless, we'll go ahead and we're going to continue to add these things. Okay, so at this point, we're going to go ahead and add some feet at the bottom. So go ahead and select the bottom face, start your sketch. And I just want a centered foot pad here so I could find the edge until it wakes up the center point of that. Find the edge here, wake up the center point so it's diagonal, and hit escape after you select there. Now we have a nice area where we could go to the center rectangle, lock it into the midpoint of that line, and drag out your rectangle. These little foot pads, we're going to go ahead and make them 4 in the length by 3 in the width. And then just extrude those. Go to Features, Extrude Boss, and we're going to make those 0.5 thick. 0.25 would probably work too. Alright, so we have that. And now let's go ahead and we're going to add a gusset in here. If you go and make sure you're in the Weldments Tools, find the gusset, and you'll see there's different types of gussets, polygonal or triangular, and you can set the size. It's like I want a 4x4, and select the two faces where they're going to intersect. And then down below here, you could set the gusset thickness. We'll keep it at 1/4 inch, and then the profile locations. We'll put it at midpoint. You could set it to an offset if you want. And that's pretty much it. You could also adjust the thickness on both sides, or so it's dead center. And hit the green check mark there. Alright, now at this point we're going to go ahead and mirror the legs across and everything else. So we could go, and I would suggest selecting your right plane. We'll start with the right plane. Just click one time on it. And we're going to go to Features and find the mirror tool. So our mirror plane is our right plane. That's why I pre-selected it. Now rather than Features to mirror, go to Bodies to mirror. And proceed to select all these bodies, including the gusset and the foot pad. Hit the green check mark. Do it again. Go to Mirror. This time I wasn't quick enough to pre-select it, but we're going to want to go with the front plane. And the bodies to mirror. Again, select the same bodies. And the mirror copies as well. Hit the green check mark. Alright, at this point we're ready to add some weld beads. Let's start at the bottom here. We'll start on one side, and we could go to the Weldments and find Weld Bead. Now the Weld Bead here, set it to 0.188 for the fillet radius, and we're going to use this little tool, the Smart Weld. I really like this. You click on that little button, go down here, and you just basically draw in kind of like what the weld would look like from the side profile, just across like that. You'll get a little pink line. When you get that, in this case you could go both sides, or you could just say all around. Select all around in this case. And you could define the weld symbol. So for example here we could select the weld symbol, and we'll go with the fillet. And the contour is going to be cotton. We'll go with convex. In the finishing method, we'll have it grinding. Okay, hit OK. We could continue on with this. Just hit New Weld Path, and you could zoom up here. Let's get this one. Just draw a little line between the two. Got a new Weld Path that turns yellow. You can zoom out again. Let's get this one over here. New Weld Path. This one here. New Weld Path. And then we'll get this as well. New Weld Path. And you could basically go through all these and get the same when they're very similar to each other. You can just go through. Unless there's a change, then you might have to start a new weld bead if it's different size. Oops, that last one didn't take too well there. So let's just hit apply and see what we got there. Okay. Valid selection for path 13. Do you want to proceed? No, not yet. Let's get rid of that one. Delete that. Alright, let's try that one. New Weld Path. There we go. Oops. Shoot. Anyway, it's probably not a bad idea to just go through and maybe piecemeal them, not try and put them all in at one time there. Let me just put in a couple here just to get them back in position there so you can see what they look like. That one. This one here. This corner. And then finally this one. Hit apply. And the last one, did not like, so let's delete that one again. 6. Okay, now you don't see anything in the preview unless you go to View and you have to turn on Weld Beads. And now you should be able to see the actual weld beads. Zoom up to them. And there's also the little notes that will come up on the drawing. Alright, but basically you could go through and add those on there. Also, there's some additional types of welds. Like in this case, we don't want a weld bead all the way around. Let's go back to the weld bead and we'll leave it at 188. Select this little end there. In this case, you just want both sides. You don't want all the way around. And you can also have an intermittent weld or staggered. And you can put in the weld length and the gap distance. Alright, so we have our welds in there now. Now let's go back to the FEA machine version of the close there. Now with that, we're going to get a couple of error messages, and that's because the weld bead locations are gone. What we need to do actually is we have to pick out what we want. In this case, we do want the we don't want the end cap, so hide the end cap. You can right click on it and there's suppress while we're in this configuration. Okay. Also, what we're going to do is we do want to get back these mirrored entities. So if you right click here and edit or actually unsuppress, this one too, unsuppress it, you might have to actually edit those features if you right click on it. The idea here was to actually just get rid of the end caps and the feet, because when we run the analysis it doesn't like those portions, and as well as the gussets. You got to take those out. I found out that the hard way. Alright, now in this case we've got these features. Let me just clear the selection, just make sure. Okay, and then we'll edit this feature just to get the whatever error messages we're getting out of the way. Error messages can slow down the system considerably, so we want to remove those. We can delete these too. We'll just leave those. Okay, so anyhow, now that we have our structural steel members here, and we've removed the end caps and basically all the additional features, we're ready to run the analysis. So we can now go to Office Products, start up SolidWorks Simulation, go to the Simulation tab. Underneath Study Advisor, I just prefer to go with New Study. Static, hit the green check mark. And now you'll see that it automatically identifies their individual bodies and puts the connection points in for us. So we have to identify fixtures. Just right click and go to Fix Geometry. And in this case, you could use the joints here. We could just click on these little yellow dots. Hit Apply. And now the external loads, go to Force. And in this case, we're just going to apply a general force over the top of the table. So we'll use the beams. And we're going to go with English here. Not always the preferred method, but we'll go with it. Select the 4 beams on the top. And then here we have to select an edge for direction. So you can select one of the vertical edges here on the structural member. And then click on Force along Z. Now you'll see it's pushing up, so hit the reverse direction so those arrows are pushing down on the beams. And we're going to put in 2,000 pounds. And go ahead and hit the green check mark to apply. Now we'll go ahead and run it. Oh, we forgot to define the material. To define the material, just right click where it says Part here and apply material to all bodies, unless it's individual. We're going to select MPA, and in this case we'll go with the structural steel A36, which for building construction is fine. We'll take it for this one. That's a structural steel, so we'll apply that. Change it to MPA, and you'll see it's about 250 for the yield strength for megapascals. And close. Now we can just go ahead and hit Run. Okay, and here we want to change this to MPA so we can see what's going on here for the stress. So just right click on it and edit the definition. And over here on the left, just set it to MPA. And if you remember, it was 250 was the yield. This is nowhere near. The highest point it's getting to is 47.8 megapascals. And so we're pretty good on this for withstanding 2,000 pounds. We could also animate it. If you right click, you can go to Animate. You can slow it down. And you could also record it. You hit Save as AVI, make a recording for it. Okay, the displacement plot, if we double click on that, here we're set to metric again. We're going to go ahead and edit the definition of that, and we're going to change it to inches. And also, if you double click on the rainbow here, on the left you'll see you can change it from scientific notation to floating, and how many decimal places you want to see. Change it to 3, and we can see at this point here where it's red, it's moving at about 14 thousandths of an inch, so not much. There's a little bit of flexion that that's going on there, but nothing that's going to be catastrophic. No failure as far as we can see. And that concludes exercise 2.